All right, this is your second 8.1, 8.2 video. Today we're going to be proving the exponent rules. I made a huge deal last video of saying like, we're going to do this in class. And then I was like, forget it. We'll do it in a video, much easier. So our essential question today is how can I prove why the exponent laws are the way they are? And the reason that I want to do this is because I think it will help you to remember the rules. Because when people see something like this, they're like, okay, I know I have to do something with the exponents here. Do I multiply them? Do I add them? I'll guess adding. And you're right, in this case, this would be my final answer. I've added the exponents. But like, why do I add them? Why do I not multiply them? That's what this video is about. We're going to prove these rules. So here's what I want you to think about. Let's not think about the final answer yet. Let's just ignore that that's there. We know that we should be adding the exponents, but let's just forget about that for now. And let's think about what x squared times x to the fifth really means. These are exponents, right? And if you see x squared, we know that this means x times x, right? This is what an exponent is. It's whatever the base is times itself this many times. So also, x to the fifth is going to be x times x times x times x times x 5 times. X times itself 5 times. So I have x squared here, and I have x to the fifth here, but I am multiplying these together. And so look at what situation I have now. Now I have just a ton of x's multiplied together. And so if I take and put these back into exponential form, how many x's do I have now? Well, looks like 1, 2, 3, 4, 5, 6, 7. This is x to the seventh, which is my answer. So why do I add them? Because really, I'm basically just saying, hey, there are 2 x's here, there are 5 more x's, we're just multiplying them all together, so x to the seventh. This is why the rule is the way it is. Pretty neat. So for these proving problems, typically we're going to kind of expand out the exponents like I did in this step. We're going to expand, and then usually we'll be able to like recondense somehow, rewrite as an exponent, and it should give us what the rule is. Okay, so let's prove the next rule. The next rule is power to a power. And again, here, I've just seen students in the past like, do I multiply, do I add? I don't know. In this case, you do multiply. 2 times 5 is 10, but like, why do we do that? So let's think about what's going on here. Again, let's kind of ignore the answer for now and just think about what's going on with this problem. Well, in the parentheses, I have something, x squared in this case, being taken to the fifth. So that means I need to multiply x squared times itself 5 times. That's what x squared to the fifth means. X squared times itself 5 times. So here, I've kind of expanded out x squared to the fifth. I've written out x squared times itself 5 times. But also, isn't it true that each of these x squares is x times x? So I have an x times x here, I have an x times x here, and here, and here, and here, and all of these x's are being multiplied together. How many total do I have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is x to the 10th, which is my answer. Notice where the multiplication comes in. I'm kind of expanding twice. It's kind of like repeated addition. I have expanded x squared to the fifth into this. But then I'm kind of repeating this process, right? And expanding again. This is multiplication, okay? So multiplying the exponents, and we can see why when we expand it all out. Let's do another one. Now you know that in this problem, I should be able to distribute the square in and get, let's see, 3 squared, x squared, y squared, squared, and I can simplify things a little. 3 squared is 9, y squared squared, multiply those exponents, that's y to the fourth. But the question is, why? Why is this the case? Well, again, if we expand What this means is this is a base, this is something times itself twice. So this is 3xy squared times 3xy squared. That's what it means to square 3xy squared. But I can expand even further. I know that these y squares are y times y. I know that this y squared is also y times y. And let's just rearrange some things. I have 3 times 3, right? I have x times x. I have 4 total y's. And we can easily see, hey, 3 times 3 is 9. X times x, x squared. Y is y to the 4th. Look, my answer works. So that's why it's okay to distribute exponents in, because really what's going on is I'm just expanding things out, and then I can rearrange using the commutative property. So this step where I rearranged is an application of the commutative property. I'm just rearranging things, and that's why it's okay to distribute in. Let's just do 2 more examples. This one. Now, we're going to get into some different sorts of, things in these last 2 rules. If I have a fraction, and this will be very, very useful in the next section, I know that I need to subtract these exponents. Why? Well, on the top, x to the 5th over x2, I have 5 x's on the top. And I have 2 x's on the bottom. Now let's think about how fractions work. For example, if I have like 3 over 9, isn't it true that I can kind of divide by 3 and reduce to 1 over 3? And the reason that works is if I see something on the top that is exactly the same as on the bottom, they can cancel. So this happens to be 3 times 1. 9 is 3 times 3. Since I see a 3 on the top and the bottom, they cancel, leaving me with 1, and I'm left with 1/3. And the reason why is because anything over itself is 1. 3 over 3 is 1. Also, x over x is going to be 1. So, let's take a look at this fraction. I have an x over x. These cancel because x over x is 1. Also, the next x over x, these cancel. Essentially, I'm reducing my fraction. What am I left with? Well, I'm left with x cubed. 3 x's, x cubed. Pretty cool. So that's why I subtract, because really, within the fraction, canceling is going on. Let's just do one more example. All right, here you know that this should distribute in, and I should get 9x squared over y to the 4th. Why? Let's actually copy this out. Remember that 3x over y squared means 3x over y squared times 3x over y squared. But let's think about how fraction multiplication works now. Fraction multiplication is top times top and bottom times bottom. So 3x times 3x, 9x squared, right? Because there are 2 x's, so x squared, and 3 times 3 is 9. On the bottom, I have y squared times y squared. If you wanted, you could just say, hey, due to the rule y squared times y squared means add the exponents, I can just directly go to y to the 4th. Or if you feel like copying things out, you know that y squared is y squared is y. How many total y's do I have? Well, I have y to the 4th. So this is my answer. Very nice. So those are some techniques of proving. And hopefully, as we kind of prove our way through these different things, we can see why the exponent rules come out the way they are. Just a reminder that typically in order to prove the exponent laws, we kind of expand the exponents. So if I see an x cubed, I write it as x times x times x. And then essentially, we're either going to count up how many x's there are, or if there's a fraction like we saw in Rule 4, we might cancel. So, be ready to do these problems in class. It'll be fun, and hopefully it'll help you remember what these rules are. Au revoir.